the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
This seminar is sponsored by BEM Systems, Brown and Caldwell, and brought to you by the Stevens Institute Center for Environmental Systems.
Thank you, and thanks for showing up as well on this crazy evening. I really appreciate this opportunity to speak to you about Covanta's sustainability story. I've been with Covanta for just a little over 2 years now, and prior to that I was in the environmental consulting field. So I've learned a lot of what I do from the consulting world, but for me coming back to Covanta, or rather coming to an air and waste related field, is sort of like homecoming, because all my education was an air pollution and waste management track. So what I do at Covanta, my primary responsibility right now is to manage our environmental management information system. And by that, what I maintain is ready access to environmental data within our organization. And that data, as you can imagine, is used for compliance reporting. It's used for project development, and it's also used to inform our sustainability report. So that's kind of my primary function. With that, let's start looking at what Covanta's, let's see if I can get this right. Right. So Covanta's mission statement, how many of you here have heard of Covanta apart from my announcement of this talk? Okay, 2, 3, 4. Okay, that's good. Well, a lot of fresh ears then. So Covanta's mission is really no waste is ever wasted. And what we want to do is we believe that materials, even those that are discarded by society, by you and me and industry, those discarded materials still have value. And that value is present in the form of materials that can be recovered, in the form of energy that can be recovered. And so our mission is to make sure that we utilize those resources so that we can create we can create clean energy, and we can preserve the valuable resources that are currently present in our natural world. We do this by having an extensive network of energy from waste facilities. We'll get more into the details of what that looks like. We also have material processing facilities. We treat wastewater for reuse or for pre-treatment, or we send it off to a POTW for further treatment. And we also provide sustainability support services. So we do quite a variety quite a complex variety of operations at our facilities. At the core, sustainability at Covanta is our business, really. As when you think about what sustainability is, it's basically ensuring that you're conserving natural sources, or you're optimizing your natural resources so that there is adequate available for our consumption and for that of future generations. And so, in a nutshell, what we do at Covanta is we basically are looking to divert waste from landfills to energy from waste facilities, and we want to do that in an environmentally safe manner and in a profitable manner. So we have a true business case, a successful business case for that. So these three things, people, because we want to operate our facilities in a safe manner, people, and prosperity are the three pillars of sustainability. And as students, you must be familiar with those. So let's take a look at some classic definitions of what sustainability really is. The most common definition comes from the UN and their World Commission on Environment and Development. Sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And so the shift that has taken place in the business world is that businesses have started looking at a different bottom line. Earlier, it was simply the bottom line, which was the financial bottom line. Now, businesses are taking into account what's called a triple bottom line by incorporating social and economic and environmental issues in the same plane. Earlier, it was all about the money, right? Now we're looking at broadening that so that the overall concept allows you to incorporate just more than money. So that the approach is changing. Sustainability is also, sustainability reporting has become a common expectation in the business world. There are in the last 5 years, there's been a significant increase in sustainability reporting by S&P 500 companies. In Covanta, in the last 4 to 5 years, we've been having a lot more discussions with investors around what our sustainability goals are. So, even though for some companies, they've been doing what they call resource conservation for optimally using their natural resources. And we've been hearing about sustainability very, as a buzzword, really. A lot of attention has come to the financial world very recently and to the footsteps of Covanta even more recently. So what the investors want to know is we're providing you with funding, and we would like to understand how you plan to use that funding for opportunities and manage risks that are now associated with a lot of the global climate change challenges that are in place. So that's kind of where we're going with understanding what is this changing global climate challenge that we're all faced with. So here's some examples. How many of you are familiar with the report that came out in October of last year, the one by IPCC? Anybody? Yeah? It was actually all over the papers. This was one of the reports that was, it was a sensational announcement as far as the environment is concerned. And so that report was called, I believe it was called Global Warming 1.5 degrees Celsius. It's written and edited by some 91 scientists from 40 countries. They reviewed some 6,000 scientific studies, and they came up with their conclusions, and they provided some trends that are shown here. You can see, in the U.S., and we're feeling the effects of these already. In the U.S., the number of hot days and cool days.
You're talking about Antarctica, like ice melting, like some inches over a year or something, like by 2022, there will be some
sea level rises. So yeah, right. Those are some of the trends that were discussed in that report. Yeah. So here are some. I just put a few of the graphs up so that you get an idea of what was in that report. So you can see an increase in the number of hot days and a reduction in the number of cold days, resulting in this wider temperature shift overall. And we're starting to see that. Look at today. It's one of those real extreme type of days as well. We're also seeing an increase in the amount of damage by wildfires in the United States.
Today there was a internet showing that Chicago has the worst
Wind chill.
temperature than the Antarctica itself.
Yes, right, right. It's like the Arctic is merging in with the US. Yes, absolutely. Yeah, so that's an example. There's also a shift in the length of the growing season, as you can see in that chart over there. If, say, you're in the agricultural sector, if your growing season changes, that means there's a shift in where your production will shift to, which means less jobs in the agricultural sector, which also may mean a shift in population densities. If you have that, then you have a shift in a high amount of stress on the local resources where these populations are shifting to. So these are some trends that were being presented. What else do we have? We often hear about sea level rise, and which is especially important for communities near water bodies, near the coast, like the state of New Jersey, like New York City. We also have some larger trends that that are not directly in our face, but you can see the marine species distribution, how that is changing as well. You know, some marine species are going deeper into the ocean because they cannot withstand the hotter, the warmer water layers that are at the surface, which means that impacts your fishing industry. And then finally, we hear a lot about the increase of pH in oceans and its impact on coral reefs. So these are some major trends that are happening worldwide and that have been happening recently. So what is one of the major drivers of these changes? Any guesses? Sorry? Primary drivers of these global climate change, of these changes, is an increase in the concentration of greenhouse gases. And which of those gases, what are greenhouse gases? Yeah, carbon dioxide, methane, nitrous oxide. Let's take a look. Let's take a look at how carbon dioxide has been changing over time. So while concentrations of GHGs in the atmosphere have varied, they've been varying for quite some time. I mean, even before humans were around. But the level at which, does this point? No. Oh, okay. So, well, yeah. So you can see here, you know, the rate at which the concentration of carbon dioxide has actually changed in the last few years with the advent of fossil fuel use has been, it's absolutely unprecedented, something we've never seen before. And the same thing we see for methane. Yeah. So the trends are definitely upward. Concentrations of CO2 and methane have clearly been seen to be going up. So what do all these have to do with waste management?
What are the different colors on the right graph?
I'd have to, yeah. I'm not 100% sure.
Actually, seems to be a zoomed in.
This is, yes, but I think what he's asking is why are these colors different?
Right, because you see on the left side there are
Yeah.
specific.
Yeah, it's
Oh,
it's
I-
this
I-
section that's zoomed in, but I'd have to get back to you on
the
that.
left section is in the first place, yeah.
Yeah, I'd have to get back to you on exactly what those are. It's basically showing you generally the trend, but I don't know the details behind that. Yeah, yeah. So again, what connection do these gases have with waste management? Do they have any connection?
Well, to a large degree, landfills emit methane when they decompose anaerobic.
Yeah.
Anaerobic.
Yeah, absolutely. You're right on. So Covanta's business case basically rests on that laurel. You know, that's the business model that we have is to divert waste going to a landfill, so diverting it from a landfill to an energy to waste facility so that the amount of methane that would otherwise be generated from that landfill does not get generated. That's, if that's the takeaway you get from this seminar, then I did my job, okay? That's really all there is to it. Okay, so overall, you know, how we use and manage our wastes and materials can have a large impact on the environment. As the gentleman just stated, if you send waste to a landfill, it's going to generate methane, and the methane is a greenhouse gas. It warms the earth, and you have global climate change, right? So that's just one sliver of the whole picture. The US EPA actually conducted a life cycle analysis of materials management. And I'll get into what that is. But basically what they found is when we manage our materials, which includes providing goods and foods to the population, that whole process contributes to about 42% of the greenhouse gases that are emitted by the United States annually. Okay, so it's a pretty large portion. So if we can better manage these materials, perhaps we will be able to amount of greenhouse gases that we put out into the atmosphere.
Do you consider
That's the theory.
the exhaust from the car being
Transportation gets, yes, that's why life cycle.
also convert to carbon monoxide or carbon dioxide or methane that could be there
Exactly.
in the air?
Right. So
What's the 42%?
42% of the US's inventory of greenhouse gases comes from the manufacture
Oh, manufacturer. Okay.
of, well, I should rephrase that, comes from the overall material management of goods and foods. So manufacturing is a portion of it. So we're looking at the whole overall life cycle of materials in general, from extraction to manufacturing to transport to reuse, recycle, ultimately to disposal. The idea there is, I'm jumping the gun here a little bit, but it's a good time to discuss it so you all have an understanding. The idea is that we want to make decisions in such a way that we don't shift the burden from one industry to another. We want a more holistic approach to our policies. And so when you look at the overall life cycle of material, that's when you will be able to come to a more holistic. I'm going to address the greenhouse gases that are produced by, say, the transportation industry. But now I've shifted that perhaps to a different industry. So that's kind of why we do a life cycle analysis, okay? So coming back to the waste management aspect of material management, the US EPA and the European Union both developed these guidance hierarchies for how to best manage municipal waste. And you can see by just comparing that there's not much difference in the two hierarchies, right? They both first said the preferred method of managing waste is one, don't generate it. That's source reduction and then prevention, right? Very similar. Then they've put reuse in the same category, which is right there for Europe as well. And then you've got recycling, followed by energy recovery, treatment, and disposal, which is where this is the least preferred, the highest impact. This is the lowest impact when it comes to managing waste. So we're typically taught, there's the 3 R's of waste management. Who knows those? Reduce, reuse, recycle, right? At Covanta, we promote a 4th R, which is recover. Recover, yeah? So you could that's the part that you're throwing out. You're calling it waste, but there's still more material and more energy to recover from there. So let's see, based on these hierarchies developed by these 2 separate entities, what the overall performance is. You can see that US is failing pretty badly. We are only recycling 29% of our waste that's generated, and only 7% is actually being treated by energy from waste facilities. In contrast, when you look at Denmark and Germany, a very small portion of their waste actually goes to the landfill. You can see that 52%, 45% is recycled. In Germany, you've got 6 recycled. And then you've got anywhere from 30 to 50% that is managed by energy from waste, with very little going to landfill. Why is that? Why are their policies working and ours are not? There's actually a very physical reason for that. It's the amount of land they have. United States has abundance of land, and so the way our policies are set up is it's cheaper for us to landfill our wastes. Europe does not have that kind of land, so they have come up with using these technologies so that they can preserve their land for some other type of use. So that's the report card. Even though the United States is lagging overall, we have a bright spot. There are some more companies are pursuing sustainable management goals. And as sustainability becomes more and more of a focus for companies, we find that over 80% of S&P 500 companies are now reporting on sustainability. This is a fourfold increase since 2011. And we internally reviewed almost 80 corporate sustainability reports, and we found that 90% of the ones that we reviewed had some sort of a waste-related goal, whether it was a zero waste to landfill, recycling, GHG mitigation. And so you can see that individual companies are starting to take a more active role in the management of their waste. A quick look at what the waste picture looks like in New Jersey. We generate roughly 9.6 million tons. And I'm throwing numbers out there, million tons and million megawatts and what have you. But I didn't really understand how much that is until I went to one of our facilities. So the Newark facility that you were referring to, when I visited that facility and you stand there in front of a mountain of garbage, you realize how, and that's on a daily basis that's being managed. So you can imagine when we talk about 9.6 million tons, how much that amounts to, okay? So New Jersey is recycling about 42% of the waste that it generates. Not bad, it's pretty good. And the remaining 5.6 million tons is processed by in-state energy from waste facilities, and the rest of it goes to New Jersey landfills or it's exported out of state. Now, that basically is telling you that 4.1 million tons of waste is being landfilled. Or you can look at it another way. 75% of the waste after recycling can be processed to harness renewable materials and energies. Yes?
I'm just wondering, I don't know if you would happen to know this, but even though it's a 42% recycling rate, what's the actual acceptance rate of what is recycled? So we're recycling, we're collecting, I don't know, for example, 10 bags, 42% of those bags are collected and brought to a facility, but what percentage are actually then accepted at that facility instead of being pushed away and said we can't accept this because
Right.
it's too contaminated?
Yeah, so I don't have that number, no. There's a lot of numbers in the industry, and I'm just starting my journey here, so there's a lot I can follow up on. But thank you for that, because it's going to make me go back and learn a little bit more, too. Yeah. Right, so let's take a quick look at what Covanta does. We're headquartered in Morristown. We process roughly 20 million tons of waste annually, and we generate over 10 million megawatt hours annually, which is enough to power about 1 million homes. Okay, there are different solutions that we offer. We offer recycling of electronics. We also provide bundled service contracts to municipalities for recycling, organics, and energy recovery. And now you might say, well, if you offer that service, how come you don't know how much you're recycling? Well, we serve as a broker when it comes to recycling. Right. So we have materials that come to our material processing facilities. We separate them out, and then we find outlets for them that would end up recycling or composting or treating the wastewater. So those are those services. We also recover a lot of metal from our operations. That number should actually say 600,000. It's not 500,000 tons anymore, and that's equivalent to 5 Golden Gate bridges.
Who supply your material? You say the land,
Which material?
like you say the landfill is your source.
No, landfill is not my source. The source is
Where
the
is
county.
solid coming from? Like,
The solid waste is coming, it's the garbage that you put by your curb. That garbage, if your county has a contract with Covanta, instead of going to a landfill, it would come to our facility
so you have a contract with the city. or
with the municipality.
municipality.
Yeah,
This is also
that's our
businesses
client.
and residences.
This is businesses and residences, yes. So the businesses would send us specialty waste, be it expired, I don't know, shampoo that's sitting in the shelves of Bed Bath & Beyond, or be it expired pharmaceuticals, off-spec product from industry, but we only take in non-hazardous waste.
Okay.
Yeah, we do not process hazard, we're not allowed to.
For recycling.
No, even for energy from waste, for combustion as well, we only take
You
non-hazardous
don't
waste.
combust that.
We don't combust hazardous waste.
Okay.
Right, yeah. So we do have energy recovery facilities as well, and we also provide some support services to our clients, such as carbon offsets and RECs. And I don't think I have the bandwidth in this class to go through. Rough numbers here, real quick. We're a young company, 30 plus years only. We have about 43 EFW facilities. We employ 3,600 people worldwide. We have facilities in Canada, and last year we opened our first facility in Europe, in Dublin. So we are the largest EFW operator in the world at this time. This is where I need Samir to give you a virtual tour of what we do at one of our energy from waste facilities.
We're Covanta, a world leader in providing sustainable waste and energy solutions to municipalities, businesses, and industries. If you've ever wondered what goes on behind the scenes at one of our energy from waste facilities, we'd love to show you. We're proud of our modern plants and the people who work here. So come on in. Once trucks arrive, they are weighed and checked in before heading inside to the tipping hall. The waste is unloaded onto the tipping floor and visually inspected for any unacceptable items, which are removed for separate recycling or proper disposal. Waste is then pushed into a storage pit and thoroughly mixed before being loaded into bins, which we call hoppers, where it travels to the combustion chamber. The tipping and waste storage areas are maintained under negative air pressure to contain dust and odors. Once fed into the combustion chamber, waste is combusted at extremely high temperatures in a self-sustaining process at approximately 2,000 degrees Fahrenheit. A typical hopper load is completely combusted in 1 to 2 hours. As waste is burned, the heat converts water in the steel tube-lined walls into steam that rises through boiler tubes where it is superheated. The steam turns a turbine-driven generator to produce electricity, or may sometimes be used directly for heating or industrial processes. The electricity produced by the turbine generator is exported to local utilities for use in homes and businesses. Each ton of waste can generate 550 to 700 kilowatt hours of electricity. Steam from the process is condensed back into water and returned to the boiler tubes, making it an efficient, closed-loop system. After combustion, the volume of waste is reduced by 90%, leaving an inert ash and metal. Remaining ash is beneficially reused or landfilled as non-hazardous waste. Ferrous metals such as iron and steel are recovered using a rotating drum magnet, and non-ferrous metals like aluminum and copper are separated by an eddy current system. Collected metal is sold to be made into new products. State-of-the-art air pollution control equipment ensures that emissions are well below limits to be fully protective of human health and the environment. We neutralize acid gases using lime in a scrubber reactor and inject activated carbon for heavy metal control. We control emissions of particulate matter primarily through a bag house, which employs thousands of fabric filter bags. All flue gas must pass through the bags before exiting through the stack. Throughout this process, the control room closely monitors emissions through a real-time continuous emission monitoring system, controls steam flow, and a number of other automated systems inside the facility. Covanta is committed to providing sustainable waste and energy solutions to ensure no waste is ever wasted. At Covanta, we believe the materials discarded every day should be utilized to their fullest potential to preserve the world's valuable resources and generate clean energy for our communities and the world we live in. This is how Covanta is powering today and protecting tomorrow.
So now you know how the energy from waste facility generally works. It's basically a power plant. Our fuel is not coal or oil, it's solid waste. So keep in mind that it's even more complicated to operate than a regular power plant, a fossil fuel-fired power plant, because we have no control over our fuel. We don't know what's going to come in through that next garbage truck. And so we have to do our limited visual inspections when we have our operators who control the cranes. They're mixing the waste. They are our eyes as well. So there's a very large human component to ensuring that our operations are smooth and effective and in compliance with our permits. So here's a little bit of a difference between why one should send their bag of trash to energy from waste versus landfills, okay? Energy from waste converts solid waste, municipal solid waste, to energy in about an hour. In a landfill, that waste would be sitting there for about 100 years, decomposing and potentially leaking. Energy from waste facilities have modern emission control and monitoring that's regulated. It's required by the government. Landfills, there's no emission control, there's very limited monitoring. Energy from waste generates about 500 to 700 kilowatt hours per ton of waste, whereas a landfill that has a gas recovery system for that methane will yield about 65 kilowatt hours per ton of municipal waste. Energy from waste facilities have an oxygenated combustion process, so there is no incomplete combustion, and we get 100% avoidance of methane. So no methane is generated, whereas landfills are a leading source of methane. We recover and recycle metals. Landfills, there is no recycling or recovery opportunity. The waste that comes into an energy from waste facility is reduced in volume by 90%. So only 10% of the material that leaves the facility in the form of ash goes to the landfill. So that's a substantially less amount of land that is now needed to handle the waste. Whereas for landfills, it's a completely non-sustainable use of land. Our facilities are also zero water discharge facilities. Our systems are all closed loop with very little to no discharge. Whereas for landfills, they all generally generate leachate. There are leachate capture systems which eventually fail. And that results in groundwater contamination. So here's a very stark comparison between what happens when you send waste to a landfill versus energy from waste facility. Now,
can that 10% could be used to transportation, asphalting, or the road?
yes, that is one of our business cases, and you're getting ahead of me here, but that's good. You're getting there. So earlier I told you that the EPA found that the full life cycle analysis of materials management, which includes goods and food production, yields about 42% of US's greenhouse gases, right? So how is that analysis done? So just, we kind of touched upon this real quick, but what is life cycle analysis? That's kind of where we're going. It's a cradle to grave approach to estimate, to assess the impacts of the process and product, okay? Again, the idea is to say, all right, for a particular product that's manufactured, starting with material extraction, your ore mining, extraction, all the way through manufacturing, transportation, utilization, reuse, disposal, how much energy, how many GHG emissions are emitted in that entire process. That's the life cycle analysis process, okay? And again, the reason you want to do this is you want to avoid shifting the burden from one part of the industry to another part, because you want a holistic approach. Okay, so when we're using that life cycle analysis, this is a key slide, okay? This is where you can see what the benefits of energy from waste are from a greenhouse gas perspective. So you might say, well, you said that carbon dioxide is a greenhouse gas. You said methane is a greenhouse gas. Okay, energy from waste does not generate methane, but we do generate carbon dioxide. So you're burning trash. How can you not be contributing to greenhouse gases? Well, the case is supported because when energy from waste facilities are generating that power and emitting the CO2, they're actually managing waste as well. That's a very large component, right? Because now you're taking that ton of waste, which would otherwise go to a landfill, and you are now processing that through your facility. So let me walk you through this. When you take about a ton of municipal solid waste, roughly, using life cycle analysis, roughly 1 ton of carbon dioxide equivalents are emitted into the atmosphere, just a little more than 1 here. Now this component, this 1 ton of CO2e, is composed of 2 portions. There's a portion called the biogenic portion, which is, it consists of organics, it consists of unrecyclable paper. So that's the component that's not counted even by the EPA as an emission, because that's part of the Earth's natural carbon cycle. Okay, so when EPA does their GHG calculations for energy from waste facilities and for landfills, it does not take that biogenic portion into account. This blue portion here is the CO2 that comes from combustion of plastics. So that's the only portion that's being counted, because in order for these plastics to be manufactured, fossil fuel had been burnt. So we're trying to reduce this portion of carbon dioxide. Yeah.
I'm just a little confused, because if we're saying that 70% is not counted as an emission, but shouldn't it be counted as an emission because if you were to compost it, for example, or if you were to just not produce it in the first place?
Well, if you don't produce it in the first place, then you don't have a problem. There's nothing to really calculate.
This is just what the U.S. EPA states as its guidelines.
Yes.
Okay.
Yes. Yes. So it's basically the case for energy from waste facilities. Why is energy from waste? It's the only net negative GHG emitting industry. So when you look at the second bar here, this is the amount of CO2 that was avoided because we generated this roughly 0.75 tons of CO2 and because of the power that was generated here, we did not need to burn this much fossil fuel, right? So this is a sink, basically. Do you follow what I'm saying? Yeah. Is that clear? Okay. So the next bar over is basically the emissions that are saved by recycling the metals that we recover. Okay? So again, life cycle. Remember the life cycle perspective. If you're extracting metals, then you have CO2. Okay. That's been emitted, and that is being avoided because you've now recycled the metals. The next bar is the landfill methane that's avoided by diverting waste from a landfill to an energy from waste facility. So when you take this blue bar, this one, and the landfill methane, you actually end up with a net negative GHG factor, which means that because you've diverted that waste from the landfill to an energy from waste facility, you have resulted in a net reduction of greenhouse gases. Does that make sense?
What do you mean by fossil CO2 avoided by EFW power now? I'm a little confused by that.
Yeah, so because we generated power using waste material, that fraction, that power, which otherwise would have used fossil fuel for its generation, was avoided, right? We didn't burn that oil.
Is there like a difference between the two? So if you were going to use fossil fuel, it would have been like 1.5 tons of CO2. But since you only burned 1 ton, you saved 0.5.
I think that's what you net out, right? The
net,
second
yeah.
bar is what you net out.
The net, yeah.
Yes.
And we have 5 more minutes.
So yeah, and I have a really long presentation. So what I'm going to do is I'm going to keep the slides, and since we have just the 5, I want to try to get one more video in there so that you get more of a holistic picture of what Covanta does. A bus and come down and take a tour of our facility.
Weekdays or weekend?
It would be on a weekday.
Weekday.
It would be, yeah.
What whole day program would be like?
No, it wouldn't. It would just be a couple of hours. It's like, I think the tour would take maybe an hour or so. Yeah.
This video.
Yes, please.
If you think about protecting the environment, protecting the planet, protecting our employees, protecting the prosperity of the company, we all have a piece of that program. And so when you think about that as our overall mission, I think everybody, every employee can look at their job and say how they fit into that equation. I think we're viewed as the industry leader, but continuing to stay on top of our game and continuing to advance our capabilities is particularly important to hit that mission statement.
Sustainability isn't just the way we do our business, but it is our business. We help communities and our clients be more sustainable.
We're there to act as the vessel that provides a safe, economical, environmentally friendly way to get rid of waste.
A number of companies have a goal of zero waste to landfill. So they really have decided that from an environmental standpoint, protecting the planet, that they don't want to have their waste going into landfills and then decomposing over a roughly 50-year period. So these companies are looking to partner up with a company like Covanta, where we can take their waste and more sustainably dispose of it through an energy from waste process. And companies are embracing the fact that it's a better, more sustainable way to handle waste than taking that waste to a landfill. We're in the business of protecting the planet. Focusing first on how to do things safely is important and really should be what's foremost in people's mind when they're doing their jobs day to day. I think your talent pool needs to be a diverse talent pool because you need diversity of thought and capabilities and backgrounds in order to get the best ideas from people. When you're operating plants that are as difficult to operate as an energy from waste plant, you really need the best thinking on the job. And so we first start out by trying to attract a diverse slate of people to come to these facilities. And so our ability then to tap into that base of talent and bring those into Covanta so that we can have the best and most diverse thinking on this topic. And we're having success. When you think about protecting tomorrow, one part of that is protecting the prosperity of our company. We have shareholders, they're our owners. They expect us to be good stewards of the capital that they put into our business. We have assets on the ground now, and how do you get the most out of those assets? We take in waste, we produce power, and we can recycle metals and other material. And so using things like continuous improvement in order to get more out of the assets we have on the ground is a great way to run the business. So ultimately protecting the planet, protecting our people, protecting our prosperity, being able to focus on that mission is a job that flows across the entire corporation.
Okay. So I can talk about a couple of case studies if there's any time, or do we want me to take questions, or how do you want to do it?
It's up to you, but again, we have 5 more minutes.
We do have 5. Okay. All right. Great. So let me just talk about a couple of really neat stories here. One of these cases is where we have our facility in Niagara, and what we do there is we get mostly waste from New York City is processed up at our Niagara facility. And it's delivered via rail cars to this facility, which is actually a combined heat and power plant. So we actually deliver steam to will purchase it from us, and we also sell electricity to the grid there. But we have a very special relationship there with a company called Greenpack Mill. They manufacture lightweight liners for corrugated cardboard, which is made with 100% recycled fibers. And the way our partnership works is all the rejects and waste material that Greenpack Mill cannot use anymore is sent to Covanta for energy recovery, because there's nothing further that they can do with that. And the steam that's generated from processing their waste and other waste is then goes right back to Greenpack Mill for processing, so they can reuse it. So it's like a nice example of a circular economy, if you will. And it's a simplistic example. But another one that we like to boast about, which is very recent, is a new technology that we just announced maybe a few weeks ago. And this is going to be a technology that actually further processes the ash that's generated from our facility, because the idea is, the idea is that once the ash is generated, we want to recover all the metals that we can. We're already doing ferrous and non-ferrous metals. But there's also small metal components there. There's the zinc and tin, and there's precious metals that are still in there, because you'd be amazed at how much precious metal is recovered from garbage. So we want to remove that small metal fraction, and then what's left, the aggregate is what it's called, will be considered in the construction industry for building roadways and any other construction materials. So ideally, where we would want to be is trash comes into our facility and there's very little, not even 10% that we have now, even a much smaller portion that actually leaves their facility and gets landfilled, if at all. But that's another interesting case that we have. Yes?
Can I ask a question?
Sure.
I visited your railway facility about maybe 10 years ago.
Okay.
And I was really impressed because I couldn't smell anything.
Mm-hmm.
We even went very close to
the pit
where the garbage was, and still we couldn't. I don't know how you guys manage it. Now, your two main sources of income, the electricity you put on the grid and what you charge the counter, right?
And one more, we sell the metal that we recover.
Okay.
Yes.
But the biggest one is
the
what
tip,
you charge the
the
counter.
tipping fee, the money that we make from the waste.
So when we start charging you for our waste that we generate, what is going to happen?
When you
But
start,
right now, we pay property tax, right,
mm-hmm.
to the town, and they come to pick up our waste.
Yes.
But now we know you guys are making money from our waste, and then we turn around and we say, look, maybe we should receive some money for this waste, because I paid for it when I went to ShopRite, right?
Yeah.
The rest of it I'm giving to you.
Okay. So
Because I think at some point, people are going to wise up to that.
I would love to see that happen. You know what that would mean, though? That would mean that people would be careful also with what they're wasting. But that would be a wonderful place to be. Let's see how and when we get there. We can barely get people to, one, reduce the amount of waste that they're generating. And most people don't even know where their trash goes. Really, if you ask them, we do a lot of these workshops, and people are like, oh, I don't know, I put it by my curb.
And also in terms of climate change,
mm-hmm.
do you think CH4 is as bad as CO2?
CH4 is 30 times worse. Also, CH4 is a short-lived, it's a very active gas, so it actually lives in the atmosphere for a shorter period. And when it lives for a shorter period, it can be as potent as 80 times that of CO2. And there's something called the global warming potential. So if you look at a 20-year life expectancy of methane, you're looking at about a factor of 80. So 80 times that of CO2, it can warm the Earth. But if you look at a 100-year expectancy life, which is what most people use, you're looking at anywhere from 25 to 35 times. So yes, methane is seriously under a lot of discussion in the scientific world, and it's gained a lot of attention recently.
Yeah, but you know, the methane, it's very difficult to control because it primarily comes from termites. You know, for example, you cannot
It comes from where?
Termites.
Termites.
Yeah, termites are one of the major sources of methane emission. You know, so that is one of the issues that we cannot control, like the kind of methane that we are putting up to the atmosphere, because a lot of organic cycles are actually generating those.
Right. So that's the biogenic generation, but
you cannot control.
Landfills are number 3 in terms of methane generation, and that's definitely not a natural phenomenon.
The cattle and all that stuff, they're emitting methane.
Right.
You know, so again, methane we can do very little about. That's why again, carbon dioxide is the primary indicator.
Mm-hmm.
You know, but one question I had about your facilities, for example, in the Newark facility, what is the ratio of the electricity that you are actually using to the amount of electricity that you are actually generating?
Yeah, I don't again have the exact numbers, but the amount of electricity that we generate, we use what we need to run the plant, and then the balance is what we transfer over to the grid. So we do have a net positive on that, so we're able to make that transaction.
I think it's like 80%.
Yeah. I don't know off the top of my head.
I don't know.
Yeah. Okay.
It's like 80%, like 80, whatever you produce. So you produce 1 megawatt. You use 1 megawatt and you produce 0.8 megawatts to go back right in. That's what I remember.
Okay.
Somewhere.
Okay.
I can't confirm that.
Mm-hmm.
As part of your waste that you're collecting, I see it's mostly garbage and that sort of. Is there any liquid waste that goes into your facility also?
Sure. Yeah. We have what I mentioned earlier as material processing facilities. These are facilities which receive wastes that might be the expired shampoos and the expired other materials. So yeah, and also we provide services where we will clean out rail cars, which are carrying bulk amounts of liquids. So there's wastewater that's generated from cleaning that process. So we do get that, and we actually have a very neat operation where we can take your 5-gallon pails or your 1-gallon pails, and we separate out the plastic packaging or the plastic bottles from the liquid. And then depending on what that liquid is, we have one example where it was soap, and it was actually sent back to a manufacturer who could reuse that. But in the event that we can't do that, we will see if it qualifies to go to a wastewater treatment facility, or as we can perform some sort of pre-treatment. So the challenge, though, is there are so many different types of materials that come into our facilities that we're constantly innovating and trying to come up with ways to tackle these problems. But yes, we do have liquid wastes.
Particular to what I'm interested in is food waste.
Yes.
And I know there's a company that I've been talking to. It's called Grind to Energy.
Mm-hmm.
What they do is they take organic food waste.
And they send it to
a
an.
slurry, and I
Okay.
think they told me they bring it to a throwaway facility. I don't imagine it's your facility. Do they do that there? Or maybe
No, we don't have any anaerobic digestion at Drawway. We don't. No.
Do you have anything
don't.
to do with the sludge produced in wastewater treatment plant?
We do have some facilities that can combust sludges.
Like dewatering system should be there.
Yeah, but it's very, very few, and
Directly,
that's not our main source. Yeah.
solid waste.
Right.
This was great, but I have to stop it here because another class is coming
Yeah.
right after us. All right, it was wonderful. Thank you so
Oh,
much.
thank you. Thank you for the questions.